Good afternoon, dear students. On our previous practical lessons, we were calculating limits, and today we will use limits for other tasks. So our topic for today is continuity of functions. Let me remind you a little bit what does it mean. So here, okay, that's so thin. So here is the graph of the function, and such a function is continuous, so no breakpoints, but sometimes it can have, so in some cases it has different breakpoints or discontinuity points, so something like this. So this is the breakpoint or discontinuity point of the first type, removable discontinuity point. Also, we can have other discontinuity points, such as function jump, something like this. This is also the discontinuity point of the second type, but of the first type, and this is a jump of the function. And also we have, so for example, look like this. So discontinuity point of the second kind when limits from the left and limits from the right at the point either infinite or they don't exist. So for removable breakpoint, limits from the left and from the right are equal. For delta for function jump, they are equal, but they are not equal, but both of them are finite. Any questions for now?
No.
Okay, so if not questions, let's practice. So the first example, so task number 1. So we need to investigate function, so this function sine of x by modulo of x. So basically where the break point can be. Obviously that at point x equals 0, so not possible, but a real break point, because we cannot divide by 0. Okay, just don't mind, this is like a usual text. Well, so this is the breakpoint. Let's investigate function behavior in this point. At this point, so from the left and from the right, so -0 plus 0. So let's start calculating. So if -0, we have, so opening this module, we have -0 here, minus x. So the limit is -1 with using the first, so the first important limit, first special limit here. And for the limit from the right, we have another situation. So sine of x divided by x. So as well, the first, so this is, so different limits, so different values of the limit. So from the left, -1, from the right, just 1, +1. So it means that x is the breakpoint of the, okay, so first kind. So the jump of function. And also we need to calculate this jump value. Basically here is this. So we subtract value on the left from the value from the right. So f from +0 minus f from -0, and the value is 2. Any questions for now?
No questions.
Okay, if no questions, let's move next. So the next example. Not so we don't calculate limits for now. So the following example. So this function is continuous on its domain, and we have a discontinuity point. And so in which point? What is the point of discontinuity? Yeah, 3 is discontinuity point. Okay, what we live in this view. So, okay, so let's investigate it as well. So f from 3 minus 0. So calculating from the left. So we have indeterminate form 0 by 0, but we already know how to deal with them. So we just need to factorize the numerator, and we will receive just so very simple expression x plus 3, and it equals 6. Well, for the limit from the right, basically the situation is the same. So 6 and 6. So what does it mean? So how can we classify this discontinuity point? So when both limits are equal.
Can you remind the classification of the limits?
Okay, so if a limit from the left is equal to limit from the right, this is the breakpoint of the first kind, and this is a removable discontinuity point. If they are not equal but finite, again, the first kind, but a jump of function. And if one of them is infinite or does not exist, the second kind. So, what type of this breakpoint?
First.
Yeah, first, and can we remove this discontinuity? Daniil?
I think yes.
Yes, so this is a removable breakpoint, and how basically can we remove it? Just with extending the domain of the function. So it will look like this. So this fraction, if x is not equal to 3, and 6 if x equals 3. So that's just how we remove the breakpoint. And now the function is absolutely continuous at the whole domain. Okay, any questions? Okay, no questions. So let's move next. Another example. So I'm erasing it. So 3 in power of 1 by x minus 2. So which point can be discontinuity point?
Two.
Yeah, so x equals 2 is discontinuity point. So again, calculating limits. So at point 2 minus 0. So if I subtract 2 minus 0, so we will receive 3 in power of minus infinity, and it equals 0. So from the right, or from the left, and from the right. So if I substitute 2 plus 0 here, I will receive plus infinity in the exponent. So 3 in power of plus infinity, and it equals plus infinity. So what is the kind of the breakpoint or discontinuity point?
Second.
Yeah, so the second kind. Correct. Okay. Let's move to the next example, or you have any questions?
We can go.
Okay. Well, to understand, to define which points can be discontinuity points, first of all, we need to factorize the denominator of this exponent. So the roots are minus 4 and 1. So x plus 1, x minus 4. So just verifying x in power of 2, so minus 4x plus x, so minus 3x. Yeah, so correct. So discontinuity points are the following. X equals minus 1 and x equals 4. So 2 discontinuity points at this case. So let's investigate both of them. So firstly, so investigate in neighborhood of the point x minus 1.
Probably 1 minus 0
Yeah.
or minus 1.
Yeah. Thank you for your attention. So, indeterminate form goes away. And we basically have e in power of no, so 1 5. So e in power of -1/5. So on the left. And what about the right? Let's see. So again, the same here, and basically the same. So x equals 1, -1 is so which discontinuity point? Which kind?
Can I ask
Yes, go on.
why the function is -1 - 0? We get exponential in the power -1/5. X plus 1, and we substitute -1, it's probably 0. Or I
But so x plus 1 in the denominator and x plus 1 in the
okay, I
yeah. So
understand.
just yeah. So eliminating the indeterminate forms.
Okay, understand.
Mhm. So what about the breakpoint classification?
First.
Order.
Yes, and is it removable or jump?
Removable.
Yes, it's removable. Okay, and now we need to investigate also x equals 4. So let's go. So 4 minus 0 and 4 minus 0. So what I have here? So 1 by -0 is minus infinity. So e in power of -infinity is 0. And now let's check +0. So in this case, receiving e, so in power of 1 divided by +0. So e in power of plus infinity. So the value of the limit is plus infinity. So which kind of the discontinuity point?
Jump discontinuity.
Are you sure? So, or why do you think so? What about infinite limits?
I thought jump discontinuity because the first we get 0 and next is like jump between.
Well, basically, if we have infinite limit, so even one of them, so so just even from one side or from both sides, this is the second order discontinuity point. If here was another so finite value, it would have been a jump of the function, but this is the second kind. So do you understand now what I mean?
Yes.
Okay. Yeah, and basically the so explanation of this example, yeah. So basically no explanation, but just a solution with the minimum explanation. So yeah, I will try to add some theory here if I don't forget, if I have time for this. Okay. Basically, let me have a look how many tasks do we have and to think about if we can skip some of them. Well, I think we have enough time for now, so let's continue. Sorry, just a moment. Okay, so what is the breakpoint here?
0.
Yes, 0. And let's investigate. So what are we having here? So 2 in power over 0 here, because 2 in power of minus infinity. So 0, minus 1, and here is 0 as well. So the limit is minus 1. And what about plus 0? So we have here the indeterminate form. So plus infinity here and plus infinity here. So infinity by infinity, and we need to fix it. So we need to eliminate it. So remembering how to do it, basically. Oh, stop. Yeah, so I just skipped it here. So what we practice more with the limits calculation, it will be useful for us. So I'm adding 1 and subtracting 1. Stop. By the way, yeah, I can do another thing. Yeah, Daniel?
We need to extract the highest power.
Yes, basically it will be a simple way to solve it. Yeah, so that's that's what I just thought about. Yeah, so 2 in so here in the power of minus 1 by x, and here as well. So 1 plus and here minus. So so we divided by 2 both parts, and basically, yeah, we have so 2 in power of minus infinity, 2 in power of minus infinity, and the result is 1. So this is a jump of the function, and so jump of function, and the value of the jump, this panel again. So the value is the following. So delta f from x So we subtract f from plus 0. So we subtract f from from f plus 0 we subtract f from minus 0. So and the result is 2. Any questions about this task?
Can you explain once again how we calculate function at plus 0?
Okay, plus 0. So so you don't understand 0 and minus 0, or just this case plus 0?
Only plus 0.
Okay. For this case, I divided the numerator and the denominator by 2 in power of 1 minus x. Okay, let me first of all just write it in more detailed form. So I divided both parts of the fraction by, so moved this multiplier out of brackets. So, and canceled it. And then received this fraction. By the way, I can move brackets away. So what I have here, 2 in power of 1 divided by plus 0. So this is minus infinity. And here minus infinity as well. So 2 in power of minus infinity is 0. So if I write more detailed, so 1 minus 0, 1 plus 0, and it equals 1. So have I answered your question?
Yes, thank you.
Okay, more questions?
Yeah, about minus version. From the left, I mean.
Mm-hmm. Yes.
Can you explain all the calculations we have?
Okay. So I will write more details here. So basically, so what? Just let me clear this board. So okay, let's see just a real number. So in plus infinity. So so if the plus infinity in exponent, so we will have plus infinity as a
In
result.
minus infinity, we have 0.
Yes, in minus infinity 0. So we basically can rewrite it like this, and basically, so it will be more understandable. Yeah, if I draw infinity more understandable. So 0. So have I answered your question for now?
Yeah.
Yeah, and so instead of plus 0, minus 0, you can just substitute some very small values. For example, so let me calculate here. Okay, so 2 in power of okay. So it doesn't want us. Okay. Stop. Stop. Minus infinity. Yeah. By the way, so it must be very large power. So this very large power, and this is very small power. So you see, so in power of, so multiplied by 10 in power of minus 302. So this is just so what we have in the limit. So any questions about this example? If no questions, let we move next. Just a moment, where is my... okay, here is my file. Okay, and one more example. I guess it will be more simple, so simpler than the previous, but also we have magnitude sign. So we need to be attentive when opening it. So let's pay attention to this task as well.
Sorry, in denominator minus 5.
Yes. Thank you for your attention. Well, this panel caused the view for me. I hate it. Okay. So what is the discontinuity point?
0.6.
Yes, 0.6 or just 3/5. And then we will see which value for us will be more useful.
Oh, no.
So which form?
It is false.
Yeah,
Pi.
5/3. Yeah. So
5.3.
yeah, I just believed you without checking it.
But I made a
Okay.
mistake.
Okay, breakpoint is shorter. So this discontinuity point. Okay, so let's investigate. So f from 5/3 minus 0. So from the left. Okay, now we need to properly open this module sign. So if 5/3 minus 0. So it means that this value in the module will be less than 0. So what we have here, so it will be opened like this. So basically the result here will be -1. And if +0, okay, let me move module back. So we will have a positive value if 3 plus, 5/3 plus 0, we will receive a positive value here. So just removing this sign of the module, and the value is 1. So how can we classify the breakpoint?
Second.
Why second?
Because we have different points.
No, this is so we have two breakpoints the breakpoints of first order have two groups. So removable, okay, and removable uh, and jump, and we also have a kind of the second kind. So
So if it's not so hard, can you write all the groups and all the variants of this?
yes, well, I will add it to this file and just now for better understanding. So in a shorter way. So first kind. And it also can be divided by two groups. So if f, so f from a minus 0 equals f a plus 0. So this is the removable. And if they are not equal, so but they are finite. So not equal infinity. So this is a jump discontinuity point. And the second kind,
If they are not equal and infinity.
so if either one of them stop. So x approaches a minus 0, so equals plus minus infinity. Or, so one of them can be infinite. So it will be enough. Okay. And so plus 0 here. Or they don't, or if one of them does not exist. So have I answered your question? Just
Yes,
full
fully.
You missed
classification.
the E in one.
Sorry?
You missed the letter E in one. At least one of limits.
At least, oh, okay. I believe you will forgive me, right? Okay, let me share this information with you, and then we will continue. And then I will add it to the file. And now just a quick reminder. Okay, so let's continue. So what is the kind of the breakpoint? In this case,
It's the first jump.
yes. And the delta is the next. So the delta equals 2. So any questions for now about this task? By the way, it's F. Not E, but F. Well, I believe that for now, no questions. So let's continue to other tasks. So now we need to investigate functions and build their graphs. So 2. Okay, I will not write the function here. Yeah, Daniel, questions?
Sorry, I misclicked.
Okay. I will not rewrite this expression for the function. It is in front of our eyes. So, so now we can define a possible discontinuity point. So possible discontinuity points are the following: 0 and 2, where functions, where expressions for the functions are changing. So let's investigate. Let's investigate them. So x equals 0, x equals 2, breakpoints. So for x equals 0, So doing the same, calculating limits. And here we must be attentive. So if limit from f, limit of f from x in point -0. So from the left. So which expression do we use here? X in power of 2 or x minus 1 in power of 2?
X in power of 2.
Yes, x in power of 2, because from the left. And it equals 0, obviously. And for plus 0, which expression? X in power of 2 or x minus 1 in power of 2?
X in power x minus 1 in power of 2.
Yes, so this expression, x minus 1 in power of 2. So we need to be careful. And the result is 1. So which kind of breakpoint?
First,
Yes, first. And is it removable or is it a jump?
and jump.
Function? Yes, jump of function. And the value of the jump is 1, but let me write it in details. Okay, now let's investigate x equals 2. So f from 2 minus 0. So which expression do we use if 2 minus 0?
X minus 1 in power of 2.
Yes, x minus 1 in power of 2. So this expression is used here. 2 minus 0. So it equals 1 for 2 minus 0. And for 2 plus 0, which expression? Daniel?
5 minus 6.
Yes, 5 minus x. And it is 4. So again, which kind of breakpoint?
The same.
Yes, so the first order, the first kind, and this is a jump of the function, and the value of the jump is another, it equals 3. And the graph is here. So graph of the function. So as you see, so solid points are including, not solid excluding. Any questions for now? Okay, if no questions, moving next, let we solve example 2b, and then we will have a break. So possible breakpoints. So which possible breakpoints do we have here?
So 1.
Yes, basically 1 is a breakpoint. basically, yeah, we don't take -1 and 4 into consideration. Yeah, we can say that the function doesn't have limits from limits of -1, -0, and 4 plus 0, but it is basically not defined there. So we don't always need to mention such points, and x equals 1 is interesting for us. So let's calculate the limits. So which expression we are using? Stanislav?
2 in power of x.
Yes, 2 in power of x, and it equals 2. And for 1, so for x, so for 1 plus 0, which expression? Daniil?
X minus 1.
Yes, x minus 1. And it equals 0. So again, this is a breakpoint of so which kind? Daniil?
Jump.
Yes,
First
jump.
kind.
So first order, and this is jump of the function. And what is the value of the jump?
2.
You are wrong.
-2.
-2. Yeah, so that's why I was asking at this time, because we always subtract from f. We subtract left value, so value from the left from value from the right. So always this f from 1 plus 0 minus f from -0. And this is -2. So jump value can be either positive or negative. So this is not the absolute value. So be attentive with this. So don't confuse. So if it's negative, if this is okay. Any questions for now? Yeah, by the way, here is the graph of the function. So it looks like this.
No questions.
Okay, if no questions, let's have a break for 5 minutes and
I have some question, but not
Oh.
about the STEM. About individual home tasks. Will we have it?
Yes, definitely. If I'm not mistaken, if it should be unlocked for you or still not. Okay, I will open them from you.
Okay.
So don't worry about it. Yeah, and I have already started checking your individual tasks, so you will receive marks soon. And now let's have a break. let's continue. Okay, so we need next we need to investigate function continuity at points x equals 2, x equals 3. So basically we can see that x equals 2 is a discontinuity point. X equals 3 is not discontinuity point, but we have such a task to investigate. So let's just investigate it in different parts. So 2 minus 0, 9 in power of 1 by x minus 2. So 1 in power of so 9 in power of 1 by minus 0. So 9 in power of minus infinity, it equals 0. And what about plus infinity? So so the limit is plus infinity. So what is the breakpoint type? Breakpoint kind? Daniel?
I think second, where infinity.
Correct. Yeah, because one of limits is infinite. Okay, and also investigating for x equals 3. Yeah, Stanislav, questions?
Why do we have -2 minus 0 and -2 plus 0? Maybe just 2 plus 0 and 2 minus
Yes,
0.
yes, that was my mistake. Thank you for your attention. Mhm. Okay, so 3 minus 0, so it equals 9. And surprisingly, the same value, 9, but basically x equals 3 is not a breakpoint, and just need to summarize it. Any questions about this task?
If 3 is not a breakpoint, for which purposes we substituted?
So in our case, it was just a requirement, and that's it.
Okay, I understand. Thank you.
So it depends on tasks. So what was required, we did. Okay, and now moving to more interesting task. So we need to investigate for which values of parameters function is continuous. So basically, as we can see, x minus 5 is a breakpoint. So we need to calculate limit in the neighborhood of the x equals 5. So more practice for limits. So this is the indeterminate form 0 by 0 and how to solve it. So how to eliminate such indeterminate form. Who can remind me?
We need to construct the quadratic formula.
Yeah, so dividing and multiplying and dividing by the conjugate expression. So do this, and then we will use yeah, difference of squares. So x minus 1 minus 4. And now no indeterminate forms, so this and this will be cancelled because x minus 5, so will be reduced. So 1 remains here, and also removing brackets. And what we have, so 1 divided by, so 1 divided by 4. So that's it for limit from the left. And also we need to calculate limit from the right. Basically, we do the same operation, performing the same actions, and it will be so it will be the same value. So which parameter value must be? So a equals which number? Just to make a function continuous, to remove this discontinuity point. So so which value must be here? Any ideas?
1/4.
Yes, 1/4. So, and that's it for this case. Yeah, also will be a good idea to write, so as the final answer, write the expression for the function with the replacing parameter with the exact value. But now we will save our time and move next. Maybe any questions or no questions? Okay, if no questions, moving next. So the next function, so we have such part. So the first part is the linear part, and then a quadratic function. Basically nothing specific, so nothing that can, so basically no breakpoints should be here, no division by 0, so everything is okay. But we need to find the value of parameter a to make this function continuous. So calculating limits from at the point x equals 1. So the function is defined for all real numbers. And what expression do we use for 1 minus 0, by the way?
X plus 1.
Yes, x plus 1. And it equals 2. And for 1 plus 0,
3 minus ax in power of 2.
And basically we receive 3 minus a. So What do we have to do next? To receive the answer, which actions do we have to perform? Well, we just solve the following equation. So finding a from this equation. 2 equals 3 minus a. So simple linear equation.
A is 1.
Yes, and a equals 1. And that's it. Any questions about this task?
Oh, we made an equality because it's a
Yes.
system.
Yeah, so we made this path equal to find a. So we know that the limit from the left is 2 and the limit from the right also must be 2. And by the way, so let's calculate the function value from the right. So 3 minus 3 minus 1. Yeah, basically it equals 2. So if we substitute here equals 2, so f from okay, f from 1 plus 0, so equals 2. So if we substitute, so any questions? Okay, no questions, so moving next. So in the next example that we have, how p over 2 is a breakpoint. So we need to calculate limits in at this point. So which which expression do we use here?
Ax plus 1.
Yes, ax plus 1. And it equals
AP divided
Yeah.
by 2 plus 1.
AP by 2 plus 1. Correct. And for the right,
Sinus x plus b.
sine of x plus b.
And it'll be 1 plus b.
Yes, it equals 1 plus b. So we have one equation, but 2 variables. So what are we going to do in this case? Your suggestions?
Maybe express something.
Well, basically we can use so we can have infinite. So there are an infinite number of values that a and b can have in such case. So like so remember in systems of linear equations, so one variable is free, other variable is basis, so we can just assign any values as we want, so the one rule that this equation must be true. So your ideas, your suggestions. What are you going to suggest? Which values? Feel free.
P2 probably.
So which of P2? So A must be equal P2 or B. Okay. So what we assign 1 equals 1, A equals 1, and B will be equal P over 2, basically. So this is one variant of parameter sets. We can assign x, so we can assign even zeros both to them, and we will just have 1 for x less or equal than p by 2, and sine of x for x greater than p over 2. So any values that we want. Any questions about this task? Yeah, basically the same here, just because these values are convenient. So as I see, no questions. Okay, so let's continue. The next task. So we have the following task. So a function f from x is not defined for x. So for all of this, so in all these examples, x equals 0 is a breakpoint. So we need to define this. So we need to define breakpoint, and so we need to define function in point x equals 0. So it is the spoiler that the breakpoint is removable. But we need to calculate limits just to understand the behavior of the function in the neighborhood of 0. So for the first case, so limit of the function in -0, so the next function 1 plus x in a power over n. Damn it. -1 equals x. Divided by x. So what do you remember about equivalences in this? So chain of infinitesimal equivalences, equivalent functions. So how can we replace
X equivalent sine x, tangent x.
So we need
and some more.
well, there are a lot of different equivalences basically we can use. So which is important for us in our case? Well, I will just write it down for you. So this expression is equivalent to the next. So nx. So this is useful equivalency. So and the result is n. And for x approaching +0, basically we have the same situation. So yeah, always use this formula as well. Useful equivalency. And that's it. So in this case, yeah, and by the way, so as the result, we need to define a function in in 0 point. So doing the following, so performing the following action. So if x doesn't equal 0, it is given by this expression. But if x equals 0, it has value n. And that's it. Any questions for now? Okay, if no questions, moving next. Okay, I will just leave empty placeholders here to save our time. So the next example, 1 minus cosine of x by x in power of 2. So we have indeterminate form, and we need to simplify, so to transform expression in the numerator. So we can use the trigonometric formulas. So we can go to the higher power, and it will be changed to the next value. So 1/2 of sine 2x in power of 2. So the next. And now we will use the equivalences. So we remember that sine of x is equivalent to x when x approaches 0. Yeah, and also this equivalency is true when x approaches 0 as well. So moving here this value, and we will have so in the numerator we will have 4x in power of 2, and the result is 2. And analogically for plus 0, so as we can see, the situation is the same. Mykola, yeah, questions?
Yeah, last part I don't get.
This one?
Yeah, this one.
Yes, okay, so I use this equivalency. So when x approaches 0, it is so sine of x is equivalent to x as x approaches 0. So for other values, okay, so ax, it will be equivalent to ax when x approaches 0. So have I answered your question?
Yeah,
So
good.
yes. So the whole this value. So sine of 2x is equivalent to 2x, but here we have power of 2, so don't forget about it. So currently no questions, right?
Yes.
Okay, moving next. Yeah, but by the way, I need also to remove the breakpoint, and it will be the final answer. So we need to define f from 0. And if no questions, moving to the next example. Cleaning the board. I will leave these equivalences for now. So which function do we have? This one. Logarithm of, so 1 minus x minus logarithm of 1 minus x. So natural logarithm of 1 plus x minus natural logarithm of 1 minus x. And also we will use equivalences. So which equivalency do you suggest to use? You also can see such equivalences from so as consequences from the some from specific limits. Okay, I will explain you. So the next equivalency. So 1 plus x is is equivalent to the next expression. X by natural logarithm of a. So yeah, and x approaches 0, by the way. And for the natural logarithm, it will be simpler. So we will remove the fraction and it will look like this. So let's do the following. So replacing these logarithms with equivalent functions, infinitesimal functions. So it is equivalent to x. For this case, basically we can rewrite it. Yeah, let me do the next. Let me duplicate, and I can rewrite it like this: plus minus x. So this expression, it will be equivalent to minus x. So be attentive to signs. And what I will receive finally, so x minus minus x, and it will be equal to. And analogically to x approaching plus 0. It is okay, so nothing changes in this case. And to define the function, we will do the following. So the function will be equal to at point x equals 0. So it will be absolutely continuous function. Any questions about this task? Maybe about the limit, about equivalences? By the way, let me remember which equivalences we have here. Yeah, by the way, so using just these equivalences, so the limit of this of this fraction equals 1, and it means that this function in the numerator is equivalent to function in the denominator. And also this equivalency. So maybe they just were not written in the explicit form. And that's it, basically. So any questions about this task? Or no questions?
No questions.
Okay, if no questions, let's move next. Okay. So 5C. 5C is done, so 5D. And cleaning this and this. So this case. that we have. So e in power of x minus e in power of minus x divided by x. So what do we have? So again, indeterminate form, 0 by 0. And again, we can use it, so we can eliminate it with using equivalences or like a kind of just consequences from the second limit. So we can use this. Okay, so doing like this, just refreshing in your memory. So 1 plus this minus 1 plus this. And if I expand the brackets, so 1 be eliminated, so minus before e in power of minus x, so equality is not broken. And I can convert it into difference of limits, by the way. Yes, and I also can, I can move minus into the denominator. So we'll receive 1 here. So we just have so 2 as the result. And analogically to the limit from the right, because so nothing specific in this case. And how to define the function. So what should be the value at point x equals 2 to be continuous? Who can answer?
It's 2.
Yeah, it's 2. And that's it.
I have a question for the last part of the calculation when we have 2.
2.
How we get it?
Well, so this limit is so. Yeah, sorry. Yeah, my bad. Confused a little bit. So what we rewrite it? Yeah, that's a good question. So -1 here. Let me correct it. But anyway, so nothing changed here. And we need to modify it here as well. So, and just, my mistake with the signs. So just made these limits to be like consequences of the second special limit. So like this. So have I answered your question?
Yeah, now it's clear.
Yeah, so now everything is correct. No. Yeah, so everything. More questions? Okay, if no questions, we will solve one more task, one more example, and after that, and part F will be your home task, but it's quite simple, so X by cotangents, so you will solve it. But this is interesting. part. So x by sine of of 1 of x in power of 2. So basically we know that so x at 0 equals 0, this part, and what about this part? So sine of so the limit of sine of 1 by x in power of 2. So what can we tell about it? So what can we say?
It equals 1.
So if we substitute 0 here, so it will be sine of infinity, sine of plus infinity. So how can we calculate it, by the way? So do we know the value? Do you know? I don't. Okay, yeah, so that's why such a kind of misunderstanding. But what else do we know about sine and cosine? Which important property of such trigonometric functions?
Sine square plus cos square is 1.
Well, this is the main trigonometric equality, but it is useless for us now. But this is like a consequence of cosine and sine properties. So which values can sine and cosine have?
From -1 to 1.
Yes. So basically, what we can. So what we know that sine of. Okay, I will write below. So function. So this function, sine of 1 and power of 2. So the module of this function is less or equal than 1. So this function is always limited. And I guess you had such information on lectures. And function, so x, when x approaches, so just f from x equals x. So this function, when approaches 0, it is infinitesimal. So let me explain it more. So this function is limited. And yeah, so function g from x. And f from x, what we call it h from x, because f is their product. So h from x equals x, and it approaches 0 when x approaches 0. Okay, let me write in other way. So h of from x approaches 0 when x approaches 0. So it means that this limit equals 0, and that's it. So how to define this function? We just set 0, so it has value of 0 at point 0. Any questions about this task?
No questions.
So basically the product of limited and infinitesimal function also approaches zero. So it is also infinitesimal function. And that's it. Okay, any question? So more questions about individual tasks, about the whole lesson, previous lessons, and so on.
Yeah, please. And individual and allow us to complete the test of model 3.
By the way,
Give.
so a test is unlocked when you finish the module.
But I
Oh,
can't
or you
do
have
it
some.
earlier.
Sorry?
Can I do it earlier?
Okay, I will ask the lecturer about it if you have some rights, because basically, I'm not sure how it must be organized.
Okay.
Yeah, but individual tasks will be unlocked for you. More questions?
No.
Okay, so have a nice evening. Stay safe. Goodbye. Thank you for your attention.
Thank you. Goodbye.
Thank you, goodbye.
Можна не по лекції питання. Тут як
Sorry,
мені